Hello everyone. In this section, we will show an example, demonstrate how to do the network analysis in project management, where we assume the activity has deterministic time. Now this is an example where we show all the activities that are involved in the project that we need to expand our business to a new branch. So we have total 7 activities to finish, starting from decide the location and interview the right person, all the way up to the last step where we're moving to this new place. The time for each activity is given here. Notice these time are given as deterministic time, which means, for example, the locate will take 8 weeks to decide. Well, it is given as 8 weeks, so it won't be more or less than 8 weeks. It is determined. And the job will not be done before 8 weeks, but it will not be done after 8 weeks. It's exactly 8 weeks. Also, we gave the information of the immediate predecessor, which gives the relationship or the dependence relationship between different activities. For example, the number 3 activity, order furniture, can only be done after we decide the location. And the number 4 activity, hire and training, can only be done after the interview is finished. Now, given all this information, we can draw the AON diagram to show the process and the relationship of activities in this project. Since it is AON, so we put all the activity on the node. So that is where you can see for each of the node, we have the name of the activity. We have also the index of the number of activity, and also we have the estimated activity completion time, which are all given here. Now, be careful on the first one, which is S. This S is called a dummy node. A dummy node means, well, it is not a real activity in reality. It is only a node we use to simplify the structure or to make the diagram easy to understand. Here, this S stands for starting point. So we use this starting dummy node only to make or to give a unified starting point. Now, with this diagram given here, we can easily find all the possible paths from the starting to the end. Now, the end point is activity 7, which is moving. So from the starting point, we can go 1, 2, 6, 7, 1, 5, 7, and 3, 4, 7. So these are the 3 possible roads from the beginning to the end point or the end node. Now, for each path, we can add together the time we spend on every single activities to get the time we need to spend on the path. For example, the first path 1, 2, 6, 7, where we add up the time we spend on each node, we get 8 plus 6 plus 3 plus 1 will give us 18 weeks. So it means we need 18 weeks to finish all the activities follow the first path. And similarly, we can calculate the time we need to spend on the other 2 paths. 157 will take 20 weeks and 347 will take 14 weeks. Now, among these different paths, we can see there is a path that has the longest time. So here is the path 157, which will take 20 weeks to finish. This is what we call the critical path because it takes the longest time to finish. In reality, or in some problems, sometimes we may have more than one path that have the longest or they have the equal time, which are the longest times. So that means we have more than one critical path. Now, how to do the time analysis for this problem? So we first give the example of to put bracket around each of the time information, and then we try to derive the early start, early finish, late start, late finish information for each of the activity. So we start from the first activity, activity 1. Now, since this is a node directly connected to the starting point, which means it doesn't depend on any other activity, it can start from the beginning. So we have the early start equal to 0. Similarly, we can have the information that's given here. So we have the early start at 0. Given it takes 8 weeks to finish the first activity, which means the early finish, or the earliest time we can finish activity 1 will be week 8. So we have the early starting equal to 0, early finish equals to 8. Now, for activity 2 and 5, both of them follows activity 1, which means we need to finish activity 1 before we can start working on activity 2 and 5. So for both of them, they need to wait till activity 1 is finished. Since activity 1 will be finished in week 8 at the earliest, which means activity 6 and 11, the early starting time will be week 8 because they need to wait till activity 1 is done. Depend on its own activity time, we have different finish time. So for activity 2, it takes 6 weeks to finish it, and it can start in week 8. So the early finish will be 8 plus 6, which is week 14. Similarly, for activity 5, the early start is week 8, and it takes 11 weeks to finish it. So the early finish will be week 19. Now, similarly, we can derive the early start and early finish for the rest of the diagram. Now we come to the last activity, which is activity 7. Notice that there are 3 activities lead to activity 7, which means activity 7 cannot be started unless all these 3 activities are done. So here are the activity 4, 5, and 6. Now, since these 3 different activities have different early finish times, which means they will finish at different time, activity 7 cannot start until all 3 activities are done, which means we need to wait till the one that takes the longest or finish the last to finish before we can start working on activity 7. So here we have activity 6, the early finish is week 17, activity 5 has an early finish of week 19, and activity 4 has early finish of 13. Now we see that activity 5 actually will finish the last, which is in week 19, which means activity 7 cannot be started earlier than week 19, although activity 4 and 6 will finish earlier than that time, because 7 moving need to wait till all these 3 activities are finished. So the early start time for activity 7 will be week 19, and based on its own activity of 1 week, the early finish will be 20. That is what we get in this early start, early finish time. Now, we need to look at the late start and late finish so we can calculate the lag time. Now, for the early start and early finish, they start from the starting point and time 0. But for the late start and late finish, they start from the end and the starting time, or they work backward from the last time period, which is week 20. We start with the last activity first, which is activity 7. So it needs to be finished in week 20. So we put the late finish as 20, and it takes 1 week to finish it. So the late start time will be week 19 because we need to start in week 19 and it takes 1 week to finish it, so we can finish it in week 20. And then we move backward. All the 3 activities, 4, 5, 6, are the activities immediately before activity 7. Since activity 7 requires or need to start in week 19, which means activities 4, 5, 6 all need to be finished by week 19. So activity 7 can start on time. So we have the late finish time for activity 4, 5, and 6 are all set to 19 due to the requirement from activity the late start time of activity 7. And depend on its own activity time, the activity 4, 5, and 6 will have different late start time. Now for activity 6, the activity time is 3 weeks, so the late start time will be 16. Which means it can wait till week 16 to start working on it, and it still have enough time to finish in week 19, and will not cause delay in activity 7. Similarly, the starting time, the late start time for activity 5 will be 8, and for activity 4, it will be 10. And similarly, we work backward and all the way to the beginning of the activity. Now here for activity 1, which is slightly different, it has 2 activities that requires or will go from activity 1, which are activity 2 and 5. Now activity 2 requires a late start of week 10, which means as long as we can finish in week 10, we'll be fine. We will not cause any trouble. But activity 5 requires a late start of week 8, which means we need to start in week 8, so the whole process won't be delayed. Now, activity 1 goes to both of these 2 activities, which means its ending time or its finish time need to satisfy the starting time requirement of both activity 2 and activity 5. Since activity 5 has an earlier starting time requirement, which is week 8, so activity 1 need to be finished in week 8 instead of weeks 10, because if activity 1 finish in week 10, then activity 5 will be delayed, which will cause trouble for the whole project. So we pick the minimum number as our late finish time. And similarly, we can derive all the information of the late start, late finish. Now, the next question is, how can I decide what will be the slack for the activity or for a path? Now, if we take a look at an activity, we can see the slack of a task or activity is determined by the relationship between late finish, early finish, or late start and early start. So the difference between late finish and early finish, or the difference between late start and early start, will be the slack. So, for example, activity 2, the late finish is week 16 and early finish is week 14. The difference is 2. Similarly, the difference between late start and early start is 2 as well, which means activity 2 has a slack of 2 weeks. For a path, it really depends on the overall time we have. For example, if we remember the critical path, which is path 157, has a total time of 20 weeks. So if we look at the slack for path 1267, which has a total time of 18 weeks, we can see the difference is 20 minus 18 equals 2, which is actually the slack located on the path 1, 2, 6, 7 as well. However, one thing we need to remember is the slack time for all the activities located on the critical path will always be 0. Here we are meaning activities 1, 5, 7. The difference will always be 0 between the ESLS and EFLF. Because they are the critical paths, they determines when the project will be finished. There is no slack for any activities located on this critical path.